Right. Alcohol ether phenol. First question banga. Phenol CH3COCl DMF anhydrous AlCl3 100 degree. So it's price rearrangement. So you'll get ortho product, okay? OH COCH3 stabilized by what hydrogen bonding? Intramolecular hydrogen bonding. Br2CS2 para push. Bromine is bulky, so you'll get para push. And OH concentrated sulfuric acid. Sulfonation is reversible, so mainly it goes to what product? Para product at 100 degree thermodynamic product. Okay. At 25 degree it would have been ortho, at 100 degree it will be what product? Para product. And OH COH Br2H2O. This ipso substitution takes place. So all the three positions what will come to away. So correct answer will be, what's the correct answer? BC. BC. Yeah, plus 4 minus 1. BC. Minus 2 minus 1. Plus 4 minus 1. Partial mark also. Second question. OH CH2OH. Excess NaOH. NaOH abstract proton from phenoxide ion, but it is not that much quantity. It's reversible but very less. So mainly it will be CH2OH. And one equivalent CH3I, obviously phenoxide ion act as a nucleophile, so you will get OCH3 CH2OH. Are you getting it or not? It's a typical what reaction? SN2BH. So why it's ortho question, electrophilic substitution? Yeah, that's generally avoided by keeping DMF like solvent. Okay, it's not given, so to understand. So DMF like solvent, yes, you will get oxygen only. It preserves the nucleophilic strength of O minus, so you get that attack. So this is B. NaH excess. NaH excess what does? Next reaction, it removes proton both. Now you are treating one equivalent of CH3I. Obviously, this is more nucleophilic than O minus. Anyway, here resonance is there. So this time this acts as a nucleophile. So CH2 OCH3 and hydrolysis in metal. This will be the major products. So correct answer will be
B. BC.
B.
C.
Every both you will get.
One is AB and one is CD, sir.
One is?
One is AB and one is CD.
Okay. So correct answer is what? B and C. Second question, B and C. Third, 1 mole fluoroglucinol. See, this phenol will exist in tautomer. The corresponding tautomer will be this is the tautomer. So when NH2OH, last class we did NH2G act as a nucleophile. So you will get imine derivative. You will get 3 places you will get imine derivative. NOH. So favoring that 3 water molecule eliminated, and yes, aromaticity compensated by what will be rather than CC bond you have CN bond. Okay, various factors. Are you getting? So this fluoroglycinol, the tautomer of that will react with NH2OH. Probably more exothermic the reaction. That's the reason it is favoring. Okay. So 3 molecules will react. Numerical plus 3 0. Fourth one, select the incorrect major product mentioned. So first one, so if you write it in char form, tertiary butoxide will be locked and OH NH2 both cis to each other. Okay, so in this case clearly what will happen when NH2 leave as N2, the group trans to that. The group trans to that has to migrate. Which is trans to that? No? There is no H. Which is trans to that? What will happen in this case? Ring contraction is the only option. This CH2 only will migrate. Ring contraction. When NH2 N2 goes, ring contraction. This is what trans to CH2. So A is false. That means here you have to select. B if you take it. B I have given the structure. So tertiary butoxide lock it at equatorial position. And OH which is cis. NH2 which is trans. So here epoxide will form. Once N2 goes, the group opposite OH act as and N2 leaves. Main will be epoxide. So that is also false. Option C is given. Tertiary butoxide. Okay. And OH is trans. Okay. We have to keep it equatorial. And NH2 OH also what will be trans. So NH2 should be like this. So in this case also what will be? Ring contraction. So but that's not written. So C also. What about D? D tertiary butoxide, keep it here. OH NH2 cis to each other but they are trans. So they are to, with respect to tertiary butoxide trans. So equatorial. NH2 has to be maximum. So in this case clearly H minus migrate. N2 leaves H minus. So it's a sixth one. But here I gave ring contraction. So that is also wrong. So the all four are incorrect. All four are incorrect. So there is no chance of negative marking in this case. Okay.
What should I say?
You know what should do?
No, nothing that not full marks.
Wait, question select incorrect. Always you are in dream. Next. Sixth. 1-methyl cyclobutene. Methyl cyclobutene, BH3 5 sorry 5 is when you treat any OH, ester hydrolysis will take place. So OH minus will attack when this become O minus OH ion. This is COO minus, like this. On acidifying, when this acetal bond, this chemiacetal also will break. So this is not chemiacetal break. this is OH. Your OH போடும்போது எல்லாம் இருக்கும். This will become aldehyde, right? CHO. And this one COOH. Now you can do again esterification, acidic medium. 1, 2, 3, 4, 5, 6. This OH acts as a nuclear cyclation. Are you getting that? So, well, right. So, 1, 2, 3. Here you got CH. So new ester. So the final product will be correct or not, no? So this will be the so A. Sixth one, 1-methyl cyclobutene. This is 1-methyl cyclobutene. There is no stereochemistry involved in that. BH3THF H2O2OH minus. So it is what? Hydroboration. Hydroboration is syn addition. So CH3 if it is fun, H and OH. Syn to H. H and OH should be syn to H. Anti-Marconic addition. Now tosyl chloride. Tosyl chloride OTS, that's all. It's a carbonyl reaction. OH act as a nucleophile. So same stereochemistry will be there. Next OH minus. Now what will be? Anti. That is SN2 reaction. Now you have inversion of configuration. So you will get OH minus. OH replaces OTS. So this is the answer. So now what is that? Tell me. Huh? A, A and D. What about C? Ma'am? C கிடையாது.
C and D same.
Yeah. C and D same, but what I gave written as A. A equal to this. So the correct answer is A and D. D எங்க போட்டிருக்கேன்னு கேட்காத. To understand. Seventh. Select the incorrect reaction in Grignard reagent. Okay. Select the incorrect reaction in Grignard reagent. So the first, you'll get MgBr like this, okay? But this is to the solvent, okay? Whatever they are using it in ether itself, because what will be more acidic is the CH bond. CH bond is weak acid than NH bond. CH bond weak bond will be what? So in the solvent itself, this will be changes like this. N minus Mg. What's happening? Children, this gives to solvent and solvent into this substrate. This change. It's not directly in the H minus polar. Okay, it gives to solvent because overall this is what more stable. CH bond. You know, CH is less acidic. more covalent than NH bond. So in the mari. Then this only act as a nucleophile. So the final will be, major product will be N, what will be? CHOH, PH. This is the final product. Clear or not? So first one is wrong. Next one, Mg ether. Okay. So what will you get? Formaldehyde and H3O plus. So Mg ether will attack ester also. Will attack what group? Ester also. Moreover, in H3O plus the hydrolysis all will be there. The new ester will form. Okay, so many side reactions will be. So B also false. What's the reason B false? Can you tell?
Ester.
Huh?
Ester.
Yeah. So you have Br. So when you have MgBr, C minus, okay. So formaldehyde, what do you get? You will get CH2OH nevertheless. This you will get CH2O minus will be there. And hydrolysis, here also bond break, this also. Okay. Maybe between this and this COH may react. Which are? This COH. Are you getting done? In the secondary alcohol, this is what will be CH2OH. This is more free to attack. Inge bond break agi, it's a different ester can form. Okay. So anyway, this hydrolysis will happen. That's sure. So that is B also false. The C, CH3CO CH3, H3O plus. So what will happen? This one. This is 5, right? So this acts as a nucleophile for acetone, CH3, O minus. But it's not given 1-2 condition. That's a problem. That means reacting in what medium? Acidic medium. Acidic medium is not possible. In a Grignard reagent directly will react with abstract proton. So the thing is, first acetone, second H3O plus fine. Without putting simply like this, that means the reaction happening in H3O plus. So it is wrong. C also. In option D, if you take it, yes, here condition is written. But the Grignard reagent first itself will abstract what will be the alcohol. It will not act as a nucleophile. Directly will take proton from the OH group. Directly take proton from OH group. Something excess, something is there, it may abstract. Otherwise, it will not do. Okay, so it's not mentioned anywhere excess Grignard reagent something. So in all 4 cases, the reaction will be what? Failed. So select the incorrect Grignard reagent all 4. Next, 8th one. Which are the following K equilibrium constant greater than 1? This is all you must know, which is strong acid, which is weak. So phenol is a strong acid than ethanol. Phenol is a strong acid than ethanol. Always strong acid, strong base proceed through in which direction? Weak acid, weak base. That direction only react. So A is true. B, tertiary butanol, okay, is a weak acid when compared to which will be? When compared to what will be? Ethanol. So B also true. It proceed. Tertiary butoxide are stronger base than, you can say inductive effect, all this there. It's a, why tertiary butanol? It's a lot of inductive effect is there. Therefore weak acid than ethanol. So obviously it goes forward direction, B also. Okay, C obviously the same. Okay, naphthol is more acidic, so it goes towards less acidic methanol. But D is obviously will be what? False. Why? D. Oh sorry. D also true. H2O stronger than tertiary butanol. So again all 4 is correct. Equilibrium constant greater than 1. All 4. Right, find the number of ethers C5H12O. C5H12O, no chance of cyclic or double bond, it's all open chain. This is chiral. So, how much is that? 7. Anything else? Next, 10th question. OOCH3, H plus H2. This what will happen? It's acetal which will be clean. Clear not? First take a protonator. This leave us methanol. Then again water act as second purifier. Okay, I'll leave. So, A is A correct. Next one. So, H plus H2. So, obviously, where this will be H plus will add here, this is the positive charge. Okay. Are you getting that? Because what is supported? Oxygen support. Same mechanism. Then this support. So what's the answer? D. D jelly. So A and D is the answer. A and D. Eleventh one, the unknown X and Y molecular formula C4H8O. Compound X bromine decolorize. So double bond written up. But Y no reaction. Sodium metal bubble will form. So maybe OH or carboxylic acid. Since one O is there, it has to be alcohol. No reaction. H2CrO4 reacting. That's Jones reaction. So alcohol group confirmed. Could be primary alcohol or secondary alcohol. Glucose plus no reaction. That means primary alcohol. So what could be the answer? Definite B. I can't say C. What's the reason? C must react with the glucose reaction. It is allylic, right? C.
C also.
Like tertiary alcohol, why tertiary alcohol will react fastest with the glucose reagent?
So it's not allylic, sir.
Huh?
Like this. Red 2 bonds.
Oh, it's not allylic. C, பாருங்க. CH2O is found as allylic carbocation only.
X very basic class, sir.
Huh?
X very basic class.
X very basic. Correct or not? So you go for answer B and C, I know that. Even you go for answer in that scenario, what will be? D also, what is that? So the only answer is correct, B only. புரிஞ்சதா இல்லையா? சலைனிக்னால it react faster with glucose. Select the correct major product as indicated. A, DMSO, since polar aprotic solvent, so O only acts as a nuclear. Okay, it preserves the electron density around oxygen. If it is polar protic, then what will be solvation, all this will disturb. So A is wrong, so it should be O should be attacking it. B, THO2. THO2 is some kind of like sterically inlet dehydrating agent. So B is true. The double bond is not forming thermodynamic alkene. Okay. So C, HI. The mechanism will be what? Tertiary. So SN1 mechanism. Right? So C is true. Correct or not? So you have ether like this O and CH3. When you treat with HI, first protonate, so you get what carbocation? OH, it's a secondary, right? Which what will be? Secondary. So C is false again. So OH, I minus approach which direction? Steric free side. Steric free side. If it is here also methyl group, then different. It follows SN1 mechanism. Now it follow what mechanism? SN2. But this side you will get I. Here what you will get? CH3OH. Clear not? So C also false. Only B is true. What about D? B. What's the mechanism? So it's written. First, you will get a carbocation here. OH. The secondary will be SN1 like. Okay. So this alkene acts as a nucleophile. So what number? 1, 2, 3, 4, 5. Right? Here CH2OH. This is positive charge. Here water will attack OH. So correct answer. So answer will be B and D. 12th one. 13th. First mechanism is correct or not? OH so where proton first added the double bond, okay? Here getting positive charge only more favorable because oxygen support. The one get positive charge, the support also is the ring expansion also favorable because you have oxygen to support electron deficient carbon after expanding. So you will get, okay, here double bond group. Okay. So A is correct. B also correct. So see here, the proton will add here. So this itself more stable bent orbital is there. Okay, but since OH group is there, yes, ring expansion will support it. Anyway, relief you will be getting. Okay. So this bent orbital support is there. But ring expansion obviously favored by this oxygen alone there. So that will be the major. If OH is not there, okay, this is itself, here itself water will attack, then finish. Are you getting done? If OH is not there, then you could have this is a major product. But since OH is there, ring expansion definitely will happen in the major product. So you have CH3. So B also correct. C, benzylic halide is almost as good as what will be methyl SN2 reaction. It may favor SN1. Both way benzylic only will attack. By SN2 also, by what will be SN1 also. So obviously C is correct. Okay, I minus will attack benzylic side. And D again you see here, you have a benzylic halide support. It's written like this. Plus HI. So first step, obviously what will happen, this get protonated. So which side, steric free which side can bear positive charge? Obviously this is benzylic. So this break I minus approach. I minus approach.
Last is wrong, sir.
Yeah. So last is wrong. So answer will be A, B, C. Which of the following alcohols will give same alkene and reaction with the concentrated sulfuric acid? First one is obvious, which alkene. This one. Next one, it's like this. Carbocation, ring expansion. Ring expansion and also where positive charge. Again methanide shift. Again methanide shift. So this also will give same. Next, I think same. Positive charge same. What about option D? What's the difference? Option D no three.
So cyclobutane connected to one.
Cyclobutane. So here positive charge. Okay. First of all, number of carbon atom itself 7 only is given. You can rule out based on the carbon atom itself. Total has to be 8. Okay. Clear not?
Answer B, C.
So answer A, B, C. 15. How many of the following compound gives brisk efflorescence with NaHCO3? A will give, B won't, C will give because of COH group, D will give because of COH group, E, OHCH3, no, weak acid. Okay, F definitely will not give, CH2OH, there is no resonance on that. Okay, and what about the OH, CH2OH, both definitely will not give, and SO3H very strong will give, and last one will not give, that is weaker than phenol. Aromatic nala K is not 7 or something, it's around 11 pK. So you need a very strong base. Okay? NaOMe, even NaO is difficult to take. So how many? 4. 16. Find out number of alcohol that can give positive iodoform test. First one won't, second one yes, third one yes, fourth pentanol no, fifth yes, sixth no, seventh yes.
So 6 yes, no.
Huh? 6 yes, tertiary alcohol. Can't oxidize itself first of all. 2 CH3, it's a tertiary alcohol. You can't oxidize, first it cannot be converted into ketone. Okay? Tertiary alcohol cannot undergo oxidation. And last 2 will go, last 3 will go on. Ethanol will answer. This also will answer. You know, because you have active methylene group first oxidized, then it pathocam. Inga iodine, then Lee. Similarly, resorcinol also. Resorcinol also first oxidized to what will be like this double bond. Okay? So this also will. So last 3 will give iodoform reaction.